basic definitions down for probability, so let's try those in some problems. So this particular problem, they tell us that 18% of Americans got the flu in a particular year. That same year, 42% were actually vaccinated, and 5% were unlucky. They both got the flu shot, they were vaccinated, but they still contracted the flu. So whenever you have a word problem, it's my very strong recommendation that you do something like Part A. You write down all the information that they give you in probability notation. So the first bit, 18% got the flu. We're going to use F for flu. So probability of getting the flu is 0.18. So again, just translating the word problem into our math notation. The next bit of information, 42% got the flu shot or were vaccinated. So they want us to use S. So probability of getting the flu shot, about 42% of Americans got the flu shot. Then finally, 5% received the flu shot and contracted the flu. So 5% had both of these things. So remember what our notation here is. Got the flu and they were vaccinated, they got the flu shot. So there's our and symbol. Both of those things happened, and that was our unlucky 5%. So this is a really important skill to develop first. Given our word problem, translate all that probability information into our math notation. The rest should be more straightforward from there. Part B, what's the probability someone did not get the flu shot? So there's our key word, probability they did not get the flu shot. So remember our notation. We're going to use that superscript C to denote the complement. So probability they did not get the shot is 1 minus the probability they did get the shot. And some of you might be thinking, I can do all this real quick in my head and just write down the answer. Good for you, pat yourself on the back, but you do need to get in the habit of writing down this probability notation. It will make it much easier when the problems start getting more challenging. So here's the question in probability notation. Probability they did not get the flu shot is 1 minus the probability they did. And I have that written down up here. Probability of the shot was 0.42. So that tells us 42% got the shot, 58% did not. Okay. The next question, what's the probability a randomly selected American experienced getting the flu shot or getting the flu? So one or the other, or maybe both. So our key word there is or. So getting the flu or getting the shot. Remember our notation, when we see or, you're going to think that U looking symbol for union. And our formula was, well, let's add up both of those together. Again, write down the formula so you know where things are coming from. Even if you think you know what's going on, go ahead and write it down. So our formula for or was add the two together and then subtract that overlap, the probability of both of those happening. So we're not double counting that intersection or middle part. And now we're ready to go. F for flu, we have up above, was 0.18. S for getting the shot, we have up above, was 0.42. And then F and S, we have up above, that intersection was 0.05 for 5%. And if you work that out, you're going to get 0.55. So last year, about 55% of people either got the flu shot or got the flu, or maybe both of them happen. Okay. Let's check out one more example before we start adding on to this. So in this particular example, we're looking at the relationship between home team advantage across different sports. And notice we are randomly selecting a game from these 490 total games. So we can consider these equally likely. So to find probabilities, we're just going to do number of outcomes in the event out of our total possible 490 outcomes. So this one wants to know what's the probability we get a basketball game. So probability basketball. So I'm going to let basketball here just be represented with a B. And if you look at your table, here's basketball, this first column, 198 of the total games were basketball games. So you guys are welcome to just leave your answer like this. You're done. Probability of a basketball game is 198 out of 490. You need to write down this notation on the left to define what you're finding the probability of. Do not put over here P with parentheses because this is the probability. Remember, when you have P with parentheses, that's saying find the probability of this thing inside. But this is the probability itself, so when you find the number, when you find the probability, just leave it plain like that. Again, no need to simplify the fraction. That's a great final answer. If you want to write it as a decimal to have a little more intuition, go for it. Make sure you round it to 4 places, just for consistency in this class. So about 40% of the games represented are basketball games. The next one, find the probability. It's won by the home team. So I'll define that just to be H. So probability of H, the home team. Take a look at the chart. What do you guys think that is? Right, 287. Our home team, there's 287 games that were won by the home team out of the 490 total games. Now, make sure you don't just write 287. That's not a probability between 0 and 1. And again, you may leave it as a fraction, or if you want to write it as that decimal, 0.5857. Okay, next one. Probability it's basketball and won by the home team. So being kind of obvious here. B and H. So using our probability notation, basketball and home team. Now you might see this and think, oh, I need to use a formula. We had a formula for that. But remember, our and formula was only true for independent events. We're not sure if these events are independent, and in fact, they're probably not. So we can't use that formula where we just do basketball times home team. Not allowed to do that. So instead, just look at the chart. Keep it simple. If you look at the chart, basketball and home team, well, there's 127 that meet both of those criteria out of our total of 490. So done, no formula needed. 127 out of 490. And again, leave it like that or write it as a decimal, which is about 0.2592. And maybe I'll just add this note here just to be on the safe side. Let's say we cannot do probability of, and we'll write the intersection, A and, or I guess B and H in this case, B and H equals probability of B times probability of H, because we do not know if the events are independent. Okay, so be careful of that common mistake. And if you have the data in a table, it's often easy just to go ahead and read that information directly from the table. All right, our last one, getting close to the last one here. Find the probability a randomly selected game is basketball or won by the home team, so B or H. And first, let's translate the question into our probability notation, B or H. And remember our formula. Let's add the two together. Probability of H, doesn't matter which order it's in. Probability of B. Okay, so add the two. And then I need to subtract that overlap so I'm not double counting B and H. And thankfully we've labeled everything very nicely up above, so we don't need to worry about recalculating anything here. H up here was 287 out of 490. B was 198 out of 490. And then that overlap, or what they shared in common, was the 127 games out of 490. And if you work that out, you can either leave it as a fraction, don't worry about simplifying, or if you write it as a decimal, you get 0.7286. All right, then the last part here, keyword is kind of spelled out for us, not won by the home team. So using our notation, probability home team does not win. There's our complement rule, 1 minus the probability that they do. And we found earlier home team winning was 287 out of 490. And if you work that out, you're going to get 0.4143. So home team wins definitely more than half the time, loses less than half the time. So there does seem to be a clear home team advantage. Now, of course, you could just look at the chart and say, well, this is the same thing as visiting team winning. And you're absolutely right. You could just do visiting team winning out of 490.